everyone, and welcome to today's 802 Tech Talk on IEEE 802.19.3, coexistence of 802.11 and 802.15.4 in sub-1 GHz frequency bands. My name is Jennifer McLean. I'm a Senior Manager of Education Products with IEEE Educational Activities, and I'll be helping to moderate today's event. IEEE is the world's largest technical professional organization dedicated to advancing technology for the benefit of humanity. Please note a few housekeeping items before we get started. At the bottom of your screen are engagement tools that are resizable and movable, so you can move them around to make the most out of your dashboard space. If you have questions for today's panelists, you can submit them through the Q&A widget on your screen, and we'll answer as many questions as time allows. If you click the green resources icon at the bottom of your screen, you'll find more information about IEEE 802 standards and past and future virtual events. Finally, the on-demand link for today's Tech Talk will be emailed to all registrants approximately 2 hours after we finish. And if you'd like to tweet about this event, please use the hashtag IEEE Learn. Our panelists today are James Gilb, Ben Rolfe, and Jianlin Guo. Dr. James Gilb has 28 years experience in a variety of areas, including radar absorbing materials, RFIC, RF system specification and architecture development, and MAC protocols. He's been a contributor to international communication standards for 21 years, primarily in IEEE 802. He has held a variety of leadership positions in IEEE 802 and is currently the 802 Landman Standards Executive Committee's first Vice Chair and the 802.15 Working Group Technical Editor. He joined General Atomics Aeronautical Systems in 2016 as a Principal RF Systems Engineer. Ben Rolfe chairs the 802.15.4 AD Task Group, is the Vice Chair of the 802.24 Technical Advisory Group, and is the Treasurer for the 802.15 Working Group. He has been a significant contributor and member of the leadership of 802.15 Working Group for more than 15 years, and is currently the Principal Technologist for Blind Creek Associates and the Chief Technology Officer of the Ultra Wideband Alliance. Dr. Jianlin Guo received his PhD degree from University of Windsor, Canada in 1995. He is currently Senior Principal Research Scientist with Mitsubishi Electric Research Laboratories in Cambridge, Massachusetts. He's been a contributor to IEEE and the IETF standardization activities, and he's a senior member of IEEE and the 802.19.3 Task Group Technical Editor. We'd like to welcome everybody today, and I'll turn it over to James to get us started.
All right, thank you, Jennifer. I just want to point out that before we get started, I want to remind the audience that these are the views of myself and Ben and Jianlin, and so they're not the IEEE. And we're going to open the floor to questions when we finish the slide deck, so put your questions in the question and answer box as we're presenting, and we'll do the best to answer them live at the conclusion of the presentation or offline if necessary. So 802 standards play a crucial role in the global economy. They enable inventors and companies to move technologies from research into products and services. Today we're going to provide an overview of the activities within 802.19.3 for wireless coexistence in the sub-1 GHz band. You can see that 802.19 is a subgroup of IEEE 802. And we'll take it over to Ben, and you can tell us what is coexistence.
So what is coexistence? Well, it's really about resource sharing. And in this case, the main resource we're trying to share is the radio spectrum. And so a key part of the environment in which wireless systems operate, obviously. So coexistence is inevitable. And when we talk about coexistence, we can talk about both positive and negative aspects of coexistence. So positive coexistence is when systems coexist in such a way that they multiple systems can operate simultaneously without destructively interfering with each other. And of course, negative coexistence would be the opposite of that, when you have interference and degradation of performance or blocking of one or more of the services using the same bands. So there's a lot of ways of looking at coexistence. There's certainly a lot of examples of it analogous in our daily lives. We can, we coexist with other human beings whenever we are out driving our cars or in a public place, and we tend to do cooperative coexistence in many of those scenarios. There's lots of those are examples of visible coexistence where you can sort of see what you're coexisting with. When we talk about radio-based systems, we don't necessarily see the other systems that we have to coexist with. We might hear them, we might be able to detect their presence, or we might not be able to detect their presence. So we have this idea of visible versus invisible coexistence. But you're there anytime that you're sharing the space, sharing a resource. You're coexisting. So so the point of the 802.19 working group is to develop standards and recommended practices that promote positive coexistence, a good coexistence experience. We see, and that's really what we're trying to accomplish. So.
All right. So what are the benefits that we can expect from getting a standard that's written about coexistence? I mean, why do we want to do this?
Yeah, so there's a lot of reasons. Obviously, more efficient and effective use of a limited resource is top of the list. We all want to get more value out of the spectrum, and it's not something that we can create more of, although we do find ways to use it more efficiently, and we find ways to use parts of the spectrum that haven't been used before. As technology advances, there's an awful lot of stuff going on in the spectrum that we do use. For example, if you've used a Bluetooth headset, it operates in a shared band of 2.4 gigahertz. And if you try to use your Bluetooth headset and warm up your coffee at the same time, you probably find out that your microwave oven also uses 2.4 gigahertz, and your headphone drops out. You may see the same thing if you're too close to your 802.11 access point. Or one of my favorite examples in 2.4 is that there's a number of companies that make radio telemetry for dog collars. And so it's a very, very crowded band. You have everyone and their dog transmitting in 2.4 gigahertz. So what we're trying to do is we're trying to get the most value out of the spectrum. And minimize the negative impacts of coexistence and maximize the positive. Also, sometimes having a standard, not only can we achieve or certainly promote that goal by providing ways in which implementers can address coexistence issues, but also sometimes we can even influence regulations by having a standard that they can reference to say, to provide what are essentially best practices. And that's what we did in 19.3, and that actually was one of the things that enabled regulators in Japan to open up the sub-gigahertz spectrums for new uses, was by having this ability to refer to some of the things that were in 19.3 as good practices for sharing the spectrum.
Okay. So can you give us a sort of an example of how coexistence, what it means in a wireless sense?
Yeah, well, so Jinlin put together these great graphics of how this is. So this is the analogy. When you have multiple people speaking in a room, it can be very sometimes difficult to hear the person that you're interested in listening to if there's multiple conversations. When the message that was transmitted isn't the message that's received because it got altered by the interference and noise. And that's the same thing that can happen in a radio spectrum. So if we look at the next slide, we see that we have not competing, but we have multiple technologies using the same spectrum. Here we're using an example of Bluetooth and Wi-Fi, which everyone knows and everyone has, they share 2.4 gigahertz. And so the information that you're trying to get from one end to the other, it fails. So if we can somehow avoid this interference, then we can improve the operation of both systems and get better performance. And one example of an early attempt was the way that Bluetooth had applied adaptive frequency hopping. So it channelized the bands so that there were gaps in between the channels that were used by 802.11, the standard that Wi-Fi is based on. And so by using multiple channels, it can find a pattern in between where it tends not to interfere or be interfered with by the Wi-Fi signal. And this is an example of active coexistence, doing something to make things work better.
All right. So what are some of the techniques that you're thinking of we're using now?
So there's a number of things that are detailed in the standard. We generally break the techniques into what we can think of as coordinated and non-coordinated techniques. So where you can have communication between systems, then you can actually coordinate the access to the spectrum. And that can be a very effective way to promote coexistence. In unlicensed spectrum, you often don't have that option. There will be uncooperating or uncoordinated systems, but you can still be aware of their presence by listening to the spectrum, and also by more like the Bluetooth example, by defining channels that are less likely to directly overlap. And so there's ways that you can avoid either with active detection of another service or just by a signal design so that you can avoid it. And so these are the general categories we see defined in the standard. Then we have a lot of strategies in there that are really designed to be a toolkit you can apply for different situations, different application environments to come up with a good positive coexistence. Again, what we're trying to do is to get the best performance out of for each of the users in the spectrum, and that leads to getting the most value out of the spectrum.
All right. So what are some of the things then that you adopted in the 802.19.3 recommended practice?
Well, as I said, we have a number of strategies. We have recommendations for how to use the channel access mechanisms defined in each standard more optimally to effectively minimize the interference between them. In some cases, this includes simply looking at the various capabilities that are already in the standard that can be configured through options or control parameters and recommending specific settings that will work in the presence of the other service. In some cases, we introduced new extensions or modifications to the mechanisms in the standard that can be used by implementers who want to improve the performance in the band. So you see some of both, using what's already in the standard, but also adding some techniques that may not be there. And one example of that is the actual CSMA channel access that's used by both 15.4 and 802.11, which are quite different algorithms. But we have both examples and recommendations for how you can set the parameters defined in the standard to get the best results under specific conditions. But we also have some additional new algorithms that can be implemented as part of the CSMA that also provide another level of improved performance in the presence of interference. So that's a couple of examples of what we have in the 19.3 recommended practice.
Yeah. So the previous example you had was Bluetooth and Wi-Fi in the 2.4 band, but this is sub-1 gigahertz. So what are the two standards that are interacting here, and how does the 19.3 work?
That's a really good question, James. What we have, so 802.15.4, sometimes known as 15.4G, because that was the amendment where the sub-gigahertz PHYs that are widely used in IoT and smart city, smart grid, a lot of very, very widely used in the energy industry, as well as other areas of low data rate IoT. And so 15.4G has found its way into all kinds of things. And it is primarily focused in bands that are below 1 gigahertz, so typically upper 800 megahertz and lower 900 megahertz bands. An example is the 902 to 928 band in the US. These are unlicensed bands, so there's rules and limits, but anyone who can comply with those rules and limits can use the band. With somewhat later, after 15.4G was published and became widely used, another amendment to 802.11 focused also on the sub-gigahertz band, 11AH, providing in many ways complementary performance capabilities, higher data rates, and different, obviously 802.11 is different MAC, but there were some applications where the 11AH was very attractive. And so this is what motivated the coexistence. Also coming into some of the same application spaces like IoT, which is a very broad category of applications. But things like environmental monitors, safety monitors in cities, surveillance systems. This is an area where 11AH has had some interest. Things like traffic light controllers and street light control. These are things where 802.15.4G are already well embedded. And you can see if these are operating in the same general environment, which is quite likely in a smart city type of application, good coexistence becomes highly valuable.
All right. Well, thanks for explaining that. So that's pretty good. We get two 802 standards that are able to share that band effectively. As a reminder, there's one more Tech Talk left that you can see on the schedule there, and open the floor for any questions. So Ben, you mentioned the 2.4 gigahertz band and coexistence with .11 and Bluetooth. What was there anything done within IEEE to handle that or to help with that coexistence problem?
Yeah, that's a great question. That's really where 802.19 was formed, was around coexistence between what became Bluetooth and 802.11 in the early days. Bluetooth, of course, grew out of 15.4.1, and both at that time we saw only the 2.4 gigahertz band being used by both of those technologies, and so the whole idea of trying to develop standards and really addressing the standards process within 802 coexistence grew out of coexistence concerns in the 2.4 band. And the very first standard, which was 802.15.2, that in 802, that was directly addressing coexistence issues, is the foundation of what's now core to Bluetooth, the adaptive frequency hopping. So, and some of the other things that are in there. So, yeah, 2.4 was really the first challenge addressed with 802 in terms of wireless coexistence.
All right. So here's another question I think people are going to ask. You mentioned that there's such a thing as positive and negative coexistences. Do we just say that the two systems coexist, or how do we go about measuring coexistence? What does it mean to say we coexist?
That's another excellent question, and one of the challenges to the group, and a lot of the work that went into the group, was deciding what metrics were meaningful. And I think I'm going to ask Jane Lin if he'd like to comment on that, because he did a tremendous amount of work in developing strategies that were applied to doing network simulations and things that allowed us to evaluate some of the recommendations that ended up in the standard.
Yes, Ben. So we have some developed some method. So you can basically you can estimate whether or not there's another network is coexisting with you. So after the standard, actually we are continuing developing this technology to how to detect the other part of the network. So that's it's really for future IoT networks. In order to make a good coexistence, first you need to know whether or not there's another network exists. So I think that we have some method developed already, and we are continued to develop. So that's a very good question to how do we do that? Yeah.
Okay.
To follow on to that a little bit, James, an example of a metric that we, again, learning from a combination of studying actual measurement studies that were done by people, going out into the real world and measuring what was in the spectrum, as well as a lot of simulation work, we discovered that you can measure performance impacts by looking at both the reliability of packet delivery, so packet loss, but also the latency involved in packet delivery. And one of the things that we learned is that the channel access mechanism used by 802.11 is you see impacts in latency from interference before you see it in packet loss because of the way the back off and deferral works.
So you really want to watch the latency more than packet loss because that'll give you an earlier warning.
It gives you it gives an earlier warning, but you see impacts in both. So it's quite, but developing the right metrics was one of the challenges for the groups. And that's one of the values that you can gain from going through the standard is you could see what metrics that we arrived at.
So Jinlin, we know Bluetooth and 802.11 obviously have different protocols, but I believe, Bluetooth's a TDMA and 4G is not. So were there different coexistence challenges because of the different natures of those two networks or the two protocols?
I would think so, because each technology has unique features. So coexistence of Bluetooth and the 802.11 will be different from the 11AH at 54G. And one feature, because 54G is not happening, but Bluetooth is happening. So coexistence will be different.
Yeah. So in the case of Bluetooth, it's always changing channels, but in 4G, it could move to ideally an empty channel potentially if it can sense it.
Right.
Okay.
Yeah, in some regions that we were studying, for example, Japan was an area of great interest. And the issue there was the way that the band isn't very big, and so if you look at 11AH, I think is it 4 channels, Jane-Lin, or 5 channels only out of the whole band?
And I don't remember how many channels, but actually we have for 54G 11AH, you can use the bandwidth at just 4.2 megahertz. It's very limited.
Yeah.
It's 4.2, only 4.2 spectrum you can use for those IoT networks. Yeah.
So that limits you to 4 or fewer channels, and so all of the 15.4 channels in that band overlap with 11AH channels. I think you're showing that here in the figure.
Yeah.
I saw we had a pretty picture there. I thought I'd show it.
Right. And so, thanks, James.
All right. So I think that brings us to the end of the Tech Talk, unless, are there any more? I didn't see, are there any more questions, Jen? Am I missing? I see there's a bunch here.
Yeah, there's a couple.
Okay. So I got one that says, is the development of IEEE 802.19.3 standard close to completion? If not, when can you give us a time frame? So Jinlin, what's the status on 19.3?
It's already published last year. So there's a standard 802 published last year.
Okay. And so what use cases are you most excited about that's going to benefit from standard IEEE standard 802.19.3?
I think, one of the typical uses, as Ben already mentioned, in the smart city, you have one of the use cases as a smart meter. It's everywhere. And then you can use for like a smart building, smart traffic, smart parking. I think, those are the popular use cases for 54G.
All right. Let's see. So, will visible light communications contribute to one of these schemes? Is another question.
That sounds like a great topic for future work.
Exactly.
For sure, that'd be something to bring to the Wireless Next Generation meeting and open up discussion on that, perhaps at our next meeting in July.
That sounds like a great idea.
Okay. I have another question here: is what kind of architecture is proposed to evaluate coexistence?
So in the standard, actually, we have a method proposed to value the performance as fearless. You don't want it to impact one system too much. So how the coexistent systems fairly share the spectrum. So that's was the one method in the 802.19.3 standard.
All right. So the next question is, we had this idea of, so how do you participate in a meeting? So the comment of, can we use visible light? We said, well, that'd be a great idea. So how do you go about joining or participating or contributing to IEEE 802, in particular 802.19.3, or 802.19 generally? Ben?
Yeah, well, it's much like life in general. The first step is to show up. So you can go to grouper.ieee.org/group/802, and you can learn about, you can find your way to the subgroup calendars, which shows all of the meetings that happen between our formal sessions. And you can also see the schedule of formal sessions. The next one coming up is the 802 plenary in July. And you can learn how to participate. Really, it's an IEEE SA. It's open to everyone. We're an individual participation group, so all you really need to do is show up.
Right. And so one of the things that you mentioned the meetings we do work by email, and we do conference call, and the July meeting is going to be hybrid. We tend to meet in person for some meetings, but there's many ways to contribute even if you can't attend an in-person meeting.
Oh yeah, very good point. Yeah, showing up doesn't require traveling or even leaving your desk anymore. That's
right. But we tend to get more work done when we're in person, but there's plenty of ways to contribute if you can't make that, and some people are limited on that.
Yes, indeed.
The other thing I would suggest is each group has a chair, and their email is on the web pages. And if you send an email to them and ask them questions about how to get involved, they can direct you to the right person. If you say, well, this is my idea, they might be able to point you in the correct direction, perhaps, of where's the best place to bring that up and start the conversation.
Yes. And each of the wireless groups, 802.11, 802.15, have a wireless next generation, James mentioned a few minutes ago. And this is specifically time allocated in each of our sessions for people to bring new ideas. So if you've got something, it can be almost anything that relates to wireless communication. And we're very happy to hear new ideas. Sometimes these new ideas turn into new work in the groups. Sometimes they just inform, and both are great.
All right. Let me see if I have any other questions. How to have a scholarship membership in IEEE? Well, that's an excellent question. So IEEE has a student membership, I know that. And then there is a way to have reduced fees for students to attend one meeting in IEEE 802 for attending it in person. So I'm not unaware, perhaps Jennifer could say if there's a thing. And then the links to the research groups. So I think I'm showing the link page, is that correct? Under additional information?
Yes.
Okay. So that's where you start. Obviously, IEEE802.org as the top. And then underneath it, you'll find links to the various subgroups that we have 802.1, which does bridging and routing. 802.3 does Ethernet, which is wired optical, and but optical over fibers, not optical in free space. 11, which handles the 802.11 MAC and wireless. 15, which is pretty much anything else wireless, including optical light communications that are done not over fibers, free space optical communications. 19 is coexistence. 18 handles radio regulatory. And 802.24 looks at sort of a broader band of how to apply these technologies at a higher level. So that's probably the best is to go to those pages and look. How to receive the participation certificate? And I'll let Jen can maybe answer that in the text, the chat.
Yes, we're happy to answer that. Everybody will receive a certificate of participation after the event. Thank you.
And did I get everybody's question? And if I didn't answer it correctly, ask again. I think I got everybody's, or I guess I have to. I think I've answered most of the questions. Okay.
Yep. Okay. We've come to the end of our event today, and I want to thank you so much, James and Ben and Jalen, for the great discussion. To follow up on a question regarding a scholarship, you could email me directly at j.mcclain, that's MCCLAIN, at IEEE.org, and I'll see if I can direct you to the right person. As noted earlier, the on-demand link for today's event will be emailed to all registrants in approximately 2 hours. We invite you to come to the next Tech Talk, which will be on coexistence, topic of coexistence, which is on June 22nd. And before you leave, if you could please complete our feedback survey via the survey tool at the bottom of your screen, we would really appreciate it. And we thank you all for your time and have a great day.